All right, hi everybody, and good evening, and welcome to Back to School night for digital electronics. And this is my presentation for the Spring 2022. So I'm Tony Mauro, by the way. Nice to meet you all virtually, and I'm gonna share my screen that has some slides on it. So give me just a second to get that, and I'll share it and make it a little bigger so we can see. All right. So again, this is for digital electronics. This is the period 2 back to school night presentation. And again, my name is Tony Mauro. So nice to meet you. Um, so based on this latest outbreak that we have, we're doing this online, obviously, but we are on campus, as you all know. Um, so that's good because this type of class, we do lots of projects. And so there's lots of hands-on learning in here. And so um, we are using a platform agnostic tool to do our schematic capture. So when we do our design work with our digital design, we use a tool that can work on either a Mac or a PC, not on a Chromebook, however, unfortunately. And I used this last year when we were shut down for the year, and it worked out pretty well. I use a tool called Logisim. Um, for all of our schematic work in the digital domain anyway. And so it works out pretty well. I have all that stuff here on in my room, on computers, and so this is the main tool that we'll use throughout the semester. We'll also be building lots of circuits, and so I have some pictures of what we build towards the end of this presentation that you'll see. But I'm sure your son or daughter will tell you all about what we're doing in class. We spend a lot of time um, doing our actual hands-on projects in here, which makes it kind of fun. I'll talk about the logistics of the class. Everything that we will be working with is electronic. So whether they're watching a video on a reference video on how to do something like wire up a board, or they're working on worksheets, it's all done electronically, and we have it all posted up on the Google Classroom for the class. And if you want to be part of that, you want to be added to it, you can add yourself or just reach out to me, and I'll have contact information at the end that you can just shoot me an email, and I'll make sure that you get added into the classroom so you can see everything that's going on. What we're going to be focusing on in this course is this is a mid-level course. I teach it as if it's my and I'll talk about my background just a bit, but I took an introductory level digital design class when I was in college, and I teach it to that. So it's actually high level and challenging at times. But most of the kids really have a good time with it, and have some fun with it. And so I'll make sure that they can make their way through the course. But we focus on what's called combinational and sequential logic design, and basically the whole design process. How do you go from, say, some kind of prompt that a customer may say, I need this designed, and the engineers will go off and design it. And so we kind of have that model in place. And so based on that, when we get to the end of the semester, the kids are going to be pretty savvy with being able to design fairly complicated circuits that are um, control mechanisms and things like that. So it's pretty fun. And they'll work in groups, so they'll have some opportunity to work in a team, and document stuff and present stuff and things like that. And so the rest of this is just what they're essentially going to be doing: designing and analyzing and building circuits. It's a focused course in design, electrical engineering type stuff design. And there's no official prerequisites because we can't have any official prerequisites in this class, but we really want the students to have our intro engineering class, because we do start introducing electronics in that class, and I make that assumption coming in, so that they have a little bit of knowledge on that, and that way we can actually hit more advanced topics as we move through. So this is like a second level. They call it the concentrator course in a pathway that I'll point out later. This is my ninth year teaching at CCA. My background is in electrical engineering, so this is actually my favorite class to teach. It's right up um, my alley in terms of my competency and what I got my degrees in and what I worked in industry for 20 some years at Qualcomm for the most part of it. A couple of years before that at a place up in LA, but mostly at Qualcomm. I started in the early 90s and I finally left in 2015, where I was doing lots of different things there. I had a really great opportunity to work in digital design, so hardware stuff. I did software design, systems level design. Um, I took the patent bar exam and I did some work with patents for a couple of years there. And so I had a really good experience when I was there. I started teaching part time at CCA in 2008, and then worked my way till finally leaving Qualcomm in 2015 and working part time um, along those ways, those years, and then finally at full time at CCA after 2015. This is a tiny picture of my family. My wife and I live in Rancho Penasquitos. My daughters live in the Bay Area, and so we get up there as much as we can to see them and to see our little grandbaby. This little one in the middle is our first grandchild, and so we're excited to see her whenever we get a chance to get up there. All right, everything is going to be electronic. Distribution and submission of assignments is through the Google Classroom. If you want access to it, you can add yourself or just reach out to me, and I'll have this contact information at the end as well. Um, Class procedures, we do pretty structured daily uh, set of activities. We'll start with a journal where the kids will come in, log in, they work on a little problem, usually something from the previous day. We'll work through that, and then I will usually give some short discussion topic of what we're studying, or a demonstration, and show them how we're going to build a circuit, or give them some circuit examples, um, or how to use a tool. And then they'll have class time for working on their assignments or their projects. Homework with a question mark after it, I don't assign it. They shouldn't have it if they are being productive in class. If they're working on it at home, and you're seeing that they're getting super stressed about it, you should let me know, because they shouldn't be. That tells me they're probably not using their time wisely in class. Um, but if they are struggling with it, they can come see me anytime, and I will help them through this material. We have the 10% grading scale, kind of traditional. I weight the projects and labs heavily, 40%. If they are participating these are these little warm up problems that we have, or they're participating with a group and working on the projects, that's another 15%. Assignments and quizzes are 30, and then we have a final exam at the quarter mark, and then I usually don't have a final exam at the end of the second quarter. I usually will have them working on a project and then presenting it to the class. So that's the breakdown. If they are missing work, students should see me. If there's a discrepancy on what is showing in areas, they should just come see me and we'll work it out. I'm pretty open to being flexible there. This is a snapshot of what they do when they design in this tool called Logisim. So these are hierarchical blocks here that have circuits inside them. And so the ones underneath it are actually the detailed implementation of some of these circuits. And so they have little components there, and they wire them together, and then they simulate them. And then we download them to either they're being downloaded to what's called a FPGA board. So we use a board called a Digilant Basis 3 board, which is, for those who know this field, it has a field programmable gate array on it, an FPGA made by Xilinx. And it's pretty powerful, very fast, and has lots of density. So we can pack a lot of circuitry in there. We do spend, though, before we get to that part, we do spend time with actual discrete components. So they get an opportunity to work with an actual proto board, putting chips into a board and wiring them up with wires, physical wires, and then testing out their board. So lots of hands-on experience through the projects in the class. All right, and I think that is it. Here's another picture. The Digilent board, this is the FPGA board that we use. And then this is on the left-hand side is so the right-hand side is the FPGA board that we use towards the second part of the class. The first part of the class is on the left side where they're actually putting chips down and they're wiring them together, and then they're lighting LEDs and throwing switches and things like that. So lots of pretty cool projects that we work on. And we use another tool called LT Spice, which is a simulation tool for the analog waveform. Towards the end, we look at a tool called Vivado, which is the way that we design the FPGA. So again, anyone who is familiar with electrical engineering or working in the field that does prototyping will probably either know these boards already or have worked with Xilinx chips and the Vivado tool suite, which is used to design Xilinx parts. And so we try to keep it as real as possible. And if there's anyone out there that has experience in this area and wants to come in and see what we're doing, or give visit the class and maybe give a talk on the day in the life of an engineer, I would be happy to host you. Please reach out if you would like. These are the pathways. Let's see, the engineering pathway here is on the right-hand side. We have a computer science pathway. I support both. On the engineering pathway, we have the intro class, and then the DE class is the class that we're talking about right now, digital electronics. We are bringing back robotics next year. We had that on kind of hiatus for a couple years, just due to the sheer number of courses that we offer. The ones that get the least number of students signing up for them usually get cut, and all of the other classes that we offer basically get packed. We get usually 40 people in them. So if we have anything that's under 40, it usually gets cut, unfortunately. So, but we're going to try to bring it back next year, and so that will be an enrichment class for us. If we finish this DE class and you're still here, you're not a senior, then the next step would be to come into the advanced engineering class. I teach that as well. We focus on more advanced direct-to-study projects and internships. And then on the left-hand side is our computer science pathway. I'm actually going to be teaching a machine learning class next year, so that's going to be added into this pathway. And I base that on an enrichment curriculum that I put together for a company that I started, that we do more advanced courses for students who basically finish all of the courses in our pathway and are looking for more things to do. So if you're interested in that, reach out to me, or this is my website. You can go check that out. Otherwise, I will be teaching these advanced topics in the next over the next couple of years. So yeah, so that's it. Thank you. My contact information is shown here. This is my email, probably the best way to get in touch with me. This is my school phone number and my extension. But again, it's probably best to just reach out to me via email. I will get that probably faster than I get my phone messages. And so if you need anything in terms of visibility of the classroom, you want to talk to me about your student, your son or daughter, or just in general, you want more information about the class, I'd be happy to share with you. All right, that does it for me. Thank you very much for listening, and have a good evening.